Now, what we're talking about in Chapter 5 is solving systems of linear equations. So we're trying to find a value that will make both equations true. We're looking at equations of lines, looking at equations of two lines, and trying to see kind of this point of intersection. What value of x and y will make both equations true? So we're trying to find values for x and y, or we won't look at x, y, z at three variables, but we'll mainly look at two, and we're trying to see what values of the two variables will make both equations true. So let's focus up here. Focus up here. So for us here, we're looking at these two variable systems of equations. So a system of linear equations is a set of two or more linear equations in the same variables, as an example shown below. So we have these two here. A solution of a system of equations is a variable, an ordered pair that is a solution for each equation. So we're looking for an x and y value, one x and one y value that will make both equations true. That will be a solution for both. Because if it's a solution for both, a value of x comma y that makes both of these equations true, then it's a solution for the system. That's what we're looking for, and that's what we're going to be doing and solving for. Now we're going to start off a little bit easier. So they gave us the 0.25. And we want to determine, is this a solution for the system? Would this 0.2 comma 5 be true for both equations? So for us to be able to determine that, I'm going to take the equation x plus y is equal to 7, and 2x minus 3y equals negative 11. I'm going to take both of these and plug the 0.25 into both of them. So when I plug it in, if I get a true statement, if it does work out, then it is a solution. Then it's a solution for the system. So what we're going to start out is we're not going to actually start out by solving today. We're not actually going to solve for it straight out. Now what they told us is they gave us a 0.25, and we want to determine, is this a solution for the system? If we plug it in to the equation, will it be true for both equations? Because if it is, then it is a solution. So what we're going to do is we're going to plug this in. So again, this is x and y. So the x value for this, we were told, is 2. So for our first one here, x plus y equals 7, I'm going to plug 2 in for x and 5 in for y. Well, 2 plus 5 is? Does 7 equal 7? So 2 comma 5, 2, 5 is a solution for the equation x plus y equals 7. It works. 2, 5 is a solution for this here. Okay. Any questions on this here so far? We're going to do the same thing for the other equation. So we'll have 2 times, well, our x value is 2. So 2 times 2. Minus 3 times, well, y is 5. So we're plugging in the values for x and y, 2, 5. Since we're given the 0.2 comma 5, well, the 2 is the x value, 5 is the y. And we have this here. Well, 2 times 2 is 4. 3 times 5 is 4 minus 15 is negative 11. And this is supposed to be, and negative 11 is equal to negative 11, yes? I just forgot to bring down the negative. Is negative 11? So that's true. Did it work for both equations? Well, yes. This 0.2 comma 5 made both statements true. So is the 0.2 comma 5 a solution for this system of equations here? Yes, because it made both equations true. We're trying to find a point that will make both equations true. And that's it. Any questions on this here? Yes. So we're good to look at the next one. Tell whether the other ordered pair is a solution of the system of linear equations. So here, the equations are written in a little bit different form. So y equals negative 2x minus 4, and y equals x plus 4. So these equations are different But we're still trying to find the same thing. We're trying to find the value x, y, that point that will make both of these equations true. And the point they gave us this time was -2, 0. So the x value is -2, and the y value is 0. So if I want to check to see, is this a solution for the system of equation, we're going to plug in that x and y value into each equation. So for this first one here, this one here, we'll plug in -2 and 0. So 0 is plugged in for y, so we have 0 is equal to -2 times our x value is -2 minus 4. Any question on this here? Any questions on how we plug this in? Now we just need to simplify. Well, 0 is as simplified as it can get. Well, -2 times -2 is what? +4, because a negative times a negative makes a, and 2 times 2 is 4. So we're almost done. Well, 4 minus 4 is, and 0 does equal 0, yes? So is -2, 0 a solution for our first equation? Well, yes, it gave us a true statement, so it is a solution. It does work. Okay? We'll need to do the same thing over here. So I'm going to plug in 0 for y, so we have 0 is equal to, I plug -2 in for x plus 4. Well, 0 doesn't change. So we plug it in. We plug in 0 for x, or 0 for y, and -2 for x. Now we can simplify. Well, 0 doesn't simplify. It's already 0. We can't do anything. -2 plus 4 is, does 0 equal 2? No. So is -2, 0 solution for this system of equations? No, because it has to be true for both of them. It has to be true for both. It has to be true for both equations. And since it's not true for both, this is not a solution for this system of equations. It has to be true for both. And that's it for this here. Questions on this here? All right, we're going to do it again for this one. And again, for this to work out, it has to be true for both statements. It has to be a solution for both of them. And the way we can do that is by plugging it in. So the x value that we have for our point, our solution, is 5. The y value is 1. So let's plug it in. So for the first one here, I plug in 5 for x, 1 for y. Well, 5 plus 1 is, and 6 is equal to 6. So this works. So we do know that 5, 1 does work for one of them. Yes? As soon as I find one that doesn't work, we know that it is not a solution. Yes? So if we plugged it into the first equation, it worked here. But if it didn't give me 6, if I didn't get 6 equals 6, do I need to check the other equation? Well, no. As soon as it doesn't work for one of them, we know it's not a solution because it has to work for both. If it doesn't work for one, it's not a solution. So let's check the other one. So here we would have 2 times 5 minus 1. Because the y value is 1, the x value is 5, we plug it in. So let's simplify here. So 2 times 5 would give me, minus 1 is, so 9 is equal to 9. So is this a solution? Yes, it is a solution because it made it true for both. It has to be true for both statements. Any questions on this here? Let's do one more of these here, and then we'll move on to the next one, because I feel like most of y'all are getting this, yes? Hopefully. Yes, we're plugging them in. So y is equal to -x plus 2. and y is equal to 3x minus 2. And the point, the solution we want to check, see if this is a solution, is negative 5 and negative 1. Well, negative 1 comma negative 5. The x value for this here is negative 1, and the y value is negative 5. So we can plug it in and see. So here we would have negative 5, because we plugged that in for y, is equal to negative 1 plus 2. Because even though, since it's negative x, well, the x value is negative 1. So we have negative 1. We have to plug that negative 1 in. So any questions on how we plugged any of this in so far? We good with this here? Now, do we normally write negative 1? Well, no. A negative and a negative make a positive. So we really have 1 plus 2. And what is 1 plus 2? So is negative 5 equal to 3? No. Well, wait a minute. Do I even have to check the other equation? No. So is this a solution? No. Because it has to work for both. Now, so far we've had the y equals don't work and the other ones do. That's not the case. Because it's more about the points making the equations true, not how they're set up. So do not, just because it's set up as this form, it does not mean that they're automatically no. It just coincidentally worked out that way. Okay? So if we're given a point and two equations to check to see if it's a solution, we do what? We plug it in. Yes? And we have two more examples of these here, but I feel like y'all are getting the hang of this, yes? Okay. Now again, we're not actually solving for anything yet. We're not having to create everything, pretty much most of it. The first part, they gave us the solution and wanted us to check it. This next part is kind of what we're going to do tomorrow, but they already kind of set it up for us, is we're going to solve these by graphing. That's the first way we can solve systems of equations, is by graphing it. And what we would do is we would graph the two equations. Now this here, so it's in your note sheet, you have these two equations and these two lines. Yes? Now what we're going to do tomorrow is they're not going to give us the graphs. So they'll give us the graph paper, but they won't give us those red lines. We're going to have to graph it. Is when we solve the systems of equations by graphing, we're trying to find an x and y value that make both of the systems of equations true, that make both equations true. A point that both lines share. So where would be a point that two lines would share the same value? Well, it'd be where they what? Where they intersect, where they cross. Because that point of intersection is a value of x and y that make both equations true. So when we solve systems of equations, we're trying to look for the point of intersection when we graph it. Well, hey, they already gave us the graph, right? So where do they intersect? Right there, yes? So I just need that point. So if we look at the x, well, I would go over to 3. It's probably easier to see on your note sheet, isn't it? The x value at 3 and the y value is at negative 2, isn't it? We go over 3 and down 2. And that's it. And that's the solution. Because we're trying to find that point of intersection where the two lines cross. 3, negative 2. Now if we plugged it in, this here would be true for both statements. It would be equal. It would work. And that's it. Let's look at the next one. So again, we're trying to find the point x comma y where these two lines intersect, where these two lines cross. And well, again, they gave us a nice little graph. Well, here they cross right down here. So what's the x and y value of that point? And negative 1. And that's it. Now be careful, make sure you don't flip the x and y values. Don't put the y value in the x spot and the x spot and x value in the y spot. Because again, as you know, with the big ideas math, it will count it wrong if you have it flipped. I would count it wrong if you have it flipped because it's talking about a different point. Okay? So especially on this one here, don't flip the x and y values. Okay. Trying to be funny. That's what happens if you flip the x and y values. It would say the same. This one doesn't change. But this one here would be different because it'd be negative 2, 3. That's a completely different point. So making sure to plug it in the correct spots. Okay. How about this one here? It'd be the point 4, negative 3. We'd be over 4 and down and negative 3. And that's really what we'd be doing to identify these. Now, the only thing that's going to really be different about tomorrow is that, well, we're actually going to have to graph these equations. We're actually going to have to go through and graph them. That's the only going to be real challenging part in seeing where they intersect. Any questions on this here? I feel like y'all have got the hang of this, yes? Y'all need to see another one of these? We're good with this here? Okay.